Think of AI as a brilliant but super literal medical intern. It desperately needs your clear instructions.
Here's the agenda: the 4 prompting levels, structuring inputs, concrete clinical examples, and medical AI ethics.
First up, prompt engineering. It's just the systematic way we talk to AI to get accurate results.
Let's break down the 4 levels of AI prompting, starting right at level 1.
Tell me about type 2 diabetes lacks context. You'll just get generic facts, not a helpful clinical simulation.
So, let's level up to level 2. Adding specific context here completely changes the AI's output.
Assigning an expert role, like an Oxford professor, gives your clinical patient simulations immediate, razor-sharp focus.
Level 3 goes even further. Now you're giving the AI highly specific examples to model its answers.
By feeding it a template, you literally show the AI exactly how your medical data should look. Finally, level 4. This is where we break complex medical requests down into super specific, manageable steps.
Telling it to think step by step forces logic, which vastly improves accuracy for those tricky diagnostic tasks.
Structured inputs boost accuracy. Just define the context, the request, the role, and the output format.
Step 1 is context. Saying you're a freshman biology student sets the absolute perfect knowledge baseline.
Step 2 is the request. Just state clearly that you need help understanding the Krebs cycle.
Step 3. Assign a role. Commanding the AI to be your college professor perfectly shapes its tongue.
Step 4. Exact output format. Asking for a 50-word FAQ guarantees a precise, easily scannable result. Combining these steps creates powerful clinical simulations, like generating an awesome interactive quiz on alcoholic cirrhosis.
But wait, this power requires care. Vague prompts can...
Okay, so now we know how to talk to an AI. Let's look at where this is having a huge impact right now, the healthcare simulation lab.
You see, the whole process of designing a medical simulation is pretty complex. It moves from an initial assessment all the way through to data analysis at the end. But the big picture here, the real takeaway, is that a well-prompted AI can help streamline nearly every single step you see along the way.
So what does that look like in practice? Well, it means AI can help write incredibly detailed patient scenarios, it can draft realistic scripts for standardized patients, and it can even generate really insightful questions for those all-important debriefing sessions. It's a massive time saver that can directly improve the quality of medical training. But, and this is a big but, all this power isn't without its perils. When you introduce a tool this transformative into a high-stakes field like healthcare, you have to be just as focused on the risks as you are on the rewards. So first up, there's the risk of hallucination, or what's more accurately called confabulation. This is when the AI confidently just makes stuff up. It presents completely fabricated information as if it's a solid fact from a textbook. In a casual setting, that might just be a funny quirk. In medicine, it's a really serious danger. Next on the list is algorithmic bias. See, an AI learns from the massive amount of data it was trained on, and if that data contains our human biases, our skewed perspectives, or underrepresents certain populations, the AI will learn and reproduce those exact same skewed patterns in its output. And that can lead to some significant and dangerous blind spots in scenarios and diagnoses. And then there's what we call the black box problem. With these incredibly complex models, we often get an answer without having any idea how the AI got there. We just can't see its reasoning. And that lack of transparency, well, it's a massive hurdle when patient outcomes are on the line and every single step needs to be justifiable. And believe me, the list doesn't stop there. We have to think about patient data privacy. We have to deal with the AI's inability to cite its sources. And maybe most importantly, we have to fight that human tendency to become over-reliant on the technology and just stop thinking critically for ourselves. So the challenge is crystal clear. How do we harness all of this amazing power while protecting ourselves from the very real peril? Well, the answer isn't to stop. It's to build a framework for safety. Calibrated prompts are a fantastic start. They really are, but they aren't enough to manage these risks across an entire organization. We need something more robust. We need a set of established policies and safety procedures. We need guardrails. And this is what those guardrails look like in practice. It's called the Safety AI Framework, and it's basically a roadmap for using AI responsibly in healthcare education. It's designed to bridge that gap between the powerful technology, institutional policy, and the day-to-day work that happens on the ground. The whole framework stands on 4 main pillars. First, purpose, making sure everyone is AI literate. Second, critical analysis, grounding any AI use in expert knowledge and solid policy. Third, and this one is so crucial, validation, making sure a human expert is always in the loop to check the AI's work. And finally, outcome, always aiming to boost performance and ensure top quality care. At its very core, this whole framework is built on a checklist for what makes an AI trustworthy. It requires that we demand human oversight, technical safety, data privacy, and complete transparency from any system we decide to use. This is the standard. This is what we have to hold AI to if we're ever going to rely on it in healthcare. So this is really where we land. AI is an incredibly powerful new instrument in the medical toolkit. It's no different than a new kind of stethoscope or a revolutionary scalpel. The technology is here. The fundamental question we all have to answer now is this: are we properly training the next generation of healthcare professionals to use it effectively, ethically, and above all else, safely?